In today's lesson, we're going to talk about atomic theory and the atom. So with the atom, it's the smallest part of matter. All matter is made up of atoms. And because we cannot see atoms, we use models to teach and learn about them. So remember, over time, atomic theory, the theory basically of the atom, has changed, and there's different models that were proposed over time due to research happening, scientific research. So scientific knowledge builds on past research and experimentation so we can learn more about nature. So with atomic theory, let's start back to 460 BC. So around that time, we have a person called Democritus, and he believed that atoms were tiny, individual, unchangeable, and indestructible. However, he was unable to test his ideas. Then we move forward to about 1800 AD. We have John Dalton. He used science to support the ideas of Democritus. And what John Dalton found out was that all elements were composed of atoms. Atoms of the same element are identical. Atoms combine in whole number ratios to form compounds. Chemical reactions are the result of atoms rearranging. Then we go to about the 1890s, where we have J. Thomson. Thomson learned that the atoms were made of smaller particles, and he used cathode arrays to figure this out. So the negatively charged particles in the atom were electrons, and they were dispersed around a positively charged particles. So with that, it was called the plum model, or the plum pudding model. So we have in this picture the red color that's charged positively. And then we have the electrons that are dispersed through it, which have the negative charge. So the protons or electrons in this model are kind of suspended like in a mold. It's called plum pudding because it's like that gel mold, and electrons are stuck in place like raisins. And then that makes the overall atom neutral in that plum pudding model. Then we go to about 1911, where we have Ernest Rutherford. So what Rutherford did was use the gold foil experiment to get the nuclear model. In this gold foil experiment, we have a radioactive source, and that source emits light towards this gold foil, and we're going to assume this is zooming up of the atoms in the gold foil. So we got the plum pudding model, where the radioactive source is going through it, and the nuclear model, which is Rutherford's model on the bottom. So his hypothesis was that, okay, this source, all those rays are going to go through the model that will make this plum pudding model the ideal model of what they thought. But instead, some of the particles reflected back instead of going all through the atom, which we see at the bottom in the nuclear model. So since some of the radioactive rays reflected back, that means, okay, there's something in the center. And then there's mostly going to be empty space everywhere else, he thought. So therefore, he thought the center had a charged particle, and that was the nucleus, hence the nuclear model. And then the rest was has electrons as the charge. 1913, there's Niels Bohr. He has the Bohr model. So he found out electrons do not randomly go hitting the nucleus. So he put them in certain areas around the center and never in between. And what he did, so we're calling those certain areas, these circles, we're calling those energy levels. So he called them energy levels. And basically, it kind of seems like there's planets orbiting the sun, where the sun's the center of the nucleus. It's not how it's actually happening, but that was how his model was shaped like. So these are like the orbit shapes, you say. And this lets us think about where electrons could actually be within the electron cloud or around the nucleus at a much simpler level. So a nice analogy for our atom is a football stadium with an atom. So the nucleus would be about the size of a marble placed on the 50-yard line of that football stadium. And then the electrons would be like mosquitoes flying around the remaining space. So most of the atom is actually empty space. So then with some more research, Rutherford discovered protons in 1919. In the 1920s, what Schrodinger did was basically discover the shape of electron clouds. And we call, again, these orbitals. And there's different shapes, like the dumbbell shape or like the four-leaf clover shape. So these are the actual shapes of the electron cloud. So they all have names as well. We have the s orbital, that's a spear shape, a p orbital, that's dumbbell shape, and the d orbital, that's like a four-leaf clover shape. And there's some more orbitals, but these are the main three you're usually first introduced to. Then we go to the 30s, where we had James Chadwick, and he discovered neutrons, and that they were in the center creating the nucleus, so that the protons don't actually repel each other, which would make sense if there's only protons in the center, because like charges repel each other. So if you have a positive next to a positive, they don't like that. They repel and go away from each other. So with the neutrons, we can now complete the view of the atom and the nucleus inside. So basically, again, we have the nucleus and high-speed electrons now around the nucleus in the electron cloud. And that fit together, so with James Chadwick getting the neutrons, Rutherford the protons, and then adding on what Schrodinger did with the shape, we can now have our current model, which is called the quantum mechanical model. And you'll see that different ways. You see it where we have the energy levels are in orbits, that's similar to the Bohr model, with the nucleus with the protons and neutrons in the center. Or sometimes you'll see it like this bottom image here. Again, you have the nucleus in the center, and then the electrons kind of just flying around the nucleus. Again, there could be future research that can tell us more about this model, but that's what we currently have from the people before, using theories and doing their own research. So again, here's a larger image. We have the current quantum mechanical model. The center is the nucleus with the protons and neutrons. These are the two images you're most likely to see. We use the one on the left a lot because it's easier for drawing the atom, and also for when we're talking about atoms bonding. So again, more about that atom structure. So now we have, again, with the nucleus that contains the protons and neutrons, and that's where most of the mass of the atom is going to be found, right? And then we have the even smaller particles, which you can hear them called subatomic particles. Sub means smaller than atomics for the atom, so smaller than the atom. Again, those are the protons, neutrons, and electrons. You should be very familiar with those names. The protons, the positive charge, we know that's in the nucleus, charge +1. It gives you the mass here, 1.67, 216 times 10 to the negative 27 kilograms. So you see how light it is. You don't need to have the mass memorized per se, but you should know the charge and where it's located. Then the neutrons, no charge. How about the same mass of the protons? And then electrons, they have a negative charge, and they are 2,000 times lighter than a proton or a neutron at 0.00091 times 10 to the negative 27 kilograms. And they orbit around the nucleus at different energy levels. And then when the atom is neutral, every atom has the equal number of electrons and protons, so the atom has no net charge, and make sure you keep that in your mind for when we're talking more about the atom and charges. That's all I have for today. Make sure to like and subscribe and ask questions and let me know what else you would like to see.